Let me give you a quick run through on the derivation of Tyrian instability. So the setup is k is on x direction, b is parallel to x OZ plane, and it's a function of y. So this is zeros order, first order. All of that are the definitions that we may use in the future. And here, any perturbation is a function of y, and periodic on x direction, and here is time dependent gamma t. So if gamma is positive, it's growing; gamma is negative, it's damping. So let's start with the first moment, or momentum equation and the induction equation. We linearize it with all those background setup. We arrive to those two equations. So we're gonna divide this to two regions. So first region is inner region, where the resistivity is not zero, but small. And outer region, we assume that the resistivity is zero or perfectly conductive. So this thin layer around y equals to 0. So this part will give us a solution, and applying this part will give us a dispersion relation, or know what to calculate the growth rate. Or this can be acting as like a boundary condition. So if we take the outer region first, perfect conductive. So if we think perfect conductive, we learn from the ideal MHD basically, then we're thinking, oh, the momentum has to be conserved. And in other words, the force has to be balanced, or the left hand side has to be 0. So we're only left with the right hand side, and that's what we have from here to here. So only right hand side survive. And this, we assume that eta is 0. So this eta hat is 0. So this is gone. So we're left with this. So from here to here, momentum equation and induction equation. We solve for the first equation. We have this expression, and if we assume that the background magnetic field is a hyperbolic tangent, plug into here and solve for the first equation again. We'll have this expression. If I plot it, it will look like this. And if we put the b back into the second equation, we'll have a plot of velocity over y over a. As you can see, it's diverging at y equal to 0. It's diverging as a v proportional to 1 over y. So it's obviously not physical to have infinite velocity at y equal to 0. So that's why we have an inner region to give it some resistance, or finite resistivity, but it's still small. So such as S is much less than 1. Lundquist number S. So we'll assume that k v double prime much greater than k square v, b double prime much greater than k square v. So it's varying faster than the k. So from here, then this is gone, this is gone, this is gone. Then we're left with this expression. And from a definition of delta prime, we can arrive to this expression. Or yes, and also we just take basically the first order of Taylor expansion. So we just assume it's changing linearly. So this is an approximation, obviously. So this is almost the definition of b double prime, and we do some algebraic trick. We have this, and similar idea here. We just think there's we just take the second order derivative linearly thinking about this as Taylor expansion. Then plug those into those two equations. We're left with this, and solve for gamma. We have this expression. As you can see, all of those are positive. So delta prime determine if gamma is imaginary or real. So if delta prime is less or equal to 0, then it's stable because gamma will be imaginary. Then it will become just a wave. If delta prime is positive, then there's a solution that is growing. So it's unstable. So this is a requirement for stabilization. And similar idea from here, we assume that we assume B0 x o prime can be expressed in this way as a Taylor expansion. Put it into here. We left with this expression. With all the definition you can see from P refers to here, and this is pretty much the induction equation with this erased, and the B double prime can be expressed in such way, and we left with this. And plug it into here, we left with this expression of with ordering of gamma, and also delta. Delta can be think as the thickness of the resistive layer, which can be used for some study. And this whole thing is a Taylor instability, and I will make a video about physical picture of that